Hello, welcome to Beginners Python and Machine Learning meetup number 54. This is a first week of the month, so we're going to start right back from the beginning. So this is for people who've never seen Python before. And what we're going to do is we're going to use Google's Python environment colab, which doesn't even need you to install Python on your own computer. So could I get people to click on the like button if they can currently see the video and that this audio is okay, or they could chat in the YouTube chat, or they can chat in the Slack channel. We've got a Slack channel where you can follow along. I've got one like, that's good. I've got 5 concurrent viewers. Okay, so to get a copy of the code that we're going to work through today, let's see, to get a copy of what we're going to work through today, I've got a link to a Google Colab notebook, and that's down in the meetup description. It's also on the YouTube. It should be below the YouTube as well, and it's also on the Slack channel. So if you click on that link, that will take you straight to Google, and it will open up a copy. This is a read-only copy of what we're going to work through tonight. So you can see, and so now we can open this one up in playground mode, which means that you can start making changes to it. So if you've clicked on open in playground, you now see this new menu here. And then you need to copy it to your own drive. That's your Google Drive. So if you copy it to your drive, I can't do it at the moment, I'm in a different browser that's not logged in. But you'll have to log in as your Google account. All right. So I'll let you do that. Now I'll go over to my Google account, which I've got running in Chrome. There it is. And so this is my copy. Now to use a Colab notebook, you can type into the cells. So these are all cells. And here's a cell. This one's a code cell, and this one here is a text cell. You can see there's buttons up here if you want to add another code cell below where you are, and this one will add a text cell. I think it's a good idea if you look at the keyboard shortcuts, and you'll see all the different things that you can do, and I'll try to tell you what keyboard shortcuts I'm using as I go through. So for example, one that I would do, Command M will convert it to a text cell, or Command MY will convert it to a code cell. And one that I use quite often is adding above and adding below. So we'll cancel out of those. We're going to be we're using Google Colab. It's very similar to Jupyter Notebooks. It's also very similar to interactive Python, also called IPython. We'll try the first cell. The first one we'll do is we'll call up the help, which we can do by typing a question mark. And you notice in code, I can put some comments there, and I start the comments with a hash sign. and then anything that I put after that won't be used. All right, so I'm going to press Shift and Enter on the question mark, and that's brought up help here about IPython. And so one of the things that's useful here is that you can type question mark and a word, and that'll print out information about that word in the help system. Okay, so now I'll close the help by clicking on the X. And we'll do a little bit of Python and see how you go. So if you've got any questions, just put the questions into the chat and I'll try to answer them as we go through. So use the Learning to Code channel on Slack or just the chat that's in YouTube. I'll follow both of those. So here's an example of variables. So variables are where we can store data when we're using Python. We can give the variables a name. We just can't use Python keywords for the name, and I'll talk more about keywords later. But any other name should be fine as long as they start with a letter. You can include numbers, you just can't start with a number. You can't include special characters, but you can include an underscore. All right, so if we want to store the number 3 in a variable that we'll make up called a, we just say a equals 3. So a equals is called the assignment, and we're just going to put the number 3 into the memory location that we're also going to call a. So if I press Shift Enter, you see it runs that. Gave me a little 2 there, so that's the second thing we run, and it stored it away in memory. Now to see what's in that memory, we can print it using the Python function print. So we say print and open parentheses, the name of the variable and close parentheses. So I'll run this one by doing Shift Enter. And you can see the number 3 is printed out below. So this is the code cell, and the output from that code cell is displayed below. So when we're using Python, that's the only way we can see the results of A. But if we're using interactive Python or these notebooks, we just have to put the name of the variable, and it will display the name of the variable for us. So if I press Shift Enter on that, you can see it does the same thing. It gives us the number 3. We can type in expressions in interactive Python, and it'll immediately calculate the value of the expression and show us the result. So if I typed in a plus 4 and press Shift Enter on that cell, I get 7, because it's taken a, which is 3, it's added 4, and given it's the result 7. So is anyone having trouble in getting the cells to run and seeing the output that's happening from those cells? No, just chat if you are. Okay, to store the result of an expression, we also use equals. So in this case, we're going to add 15 to A and divide by 4 and store the result in B. But storing the result in B doesn't actually return the value B. So if we want to see that return, we have to type B. So I'll do it without doing that. And if you see, we get nothing as an output. But if I type B in there, it says I want to know what's in B now that we've run it. And so I can run it again. I select it, Shift Enter, and now it tells me B has got 4.5 in it, which is 3 plus 15 is 18, divided by 4 is 4.5. Okay, so when you're talking about variable names, I said you can't use the Python keywords. So these 2 lines of code, Python code, will actually give us all the keywords that we can't use. So we import the keyword module and we look at the keyword list that's in that. And there we go. These are all the keywords. So they're all used. Python recognizes them as program statements, so we can't use them as variable names. So they're all the names you can't use for variables. Normally when we're using variables, we do them in lowercase, and if it's a variable name as multiple words, we'll put underscores between them. So I'm now going to create another cell below, so I can do, so if it's on Windows, I'd use Control M and then B, and it's created another cell below where I am, and I can type in a variable name here, and put a number in it, and then I can see what's in that variable name. And you see Google Colab's even worked out that these are variable names that I might want to use, so I can click on that and then press Shift Enter, and it tells me that the number 345 is stored in my variable name, my variable called a long variable name. Okay, that was a quick introduction to variables. Now we'll move on to data types. In Python, it's got a lot of different data types. We're just going to be working with a few of them today. And we can see what data type is stored in our variables or even in values. So if I use the type function, which is a Python built-in function with parentheses, and I put in what I want to find the type of, which is the A, and press Shift Enter, it'll tell me that's an int. Now I'll just do Command or Control M above to add another cell in there, and I could have found the type of an actual literal number that I've typed in rather than looking at the variable, and that should also give me an int. So ints are integers or whole numbers. They don't have any fractional part. Floats are what Python calls floating point numbers. You probably call them decimal numbers or something like that, or real numbers. So remember, B has got 4.5 in it. Well, there we go. Google Colab's even going to tell us. It's going to tell us that B is a float and it's got 4.5. But if I wanted to find the type of B, I do Shift Enter on that, and it tells me it's a float. So the way floating point numbers are stored are with a mantissa and an exponent. So if I have a look at this quite large number here that I type in, when Python displays it, it's got this part of the number on the left, which is called the mantissa, and this part on the right, which is called the exponent. So the exponent is just telling me that's times 10 to the 19th, and the bit on the left is what I'm multiplying by 10 to the 19th to give me the actual floating point number that I want, which is this number here. So it's a way of storing very large or very small numbers in a small amount of memory, and the position of the decimal point floats along the number depending on what's the value of this exponent is, and that's why they're called floating point numbers. So similarly, if I had this very small number here with lots of zeros in front of it, it's also displayed in a very similar way. It's got the mantissa there and the exponent of by 10 to the minus 14. The integers that we were dealing with before, they just use up more bytes depending on how big or small the integer is. So small integers can use a very small amount of memory, but the large integers will use more memory. Okay, I've got no questions so far, so I'll just keep powering on. We can also store text in Python, and it's stored as strings of Unicode characters, which is Python 3. In Python 2, characters were stored as bytes, so each character was 1 byte long, but 1 byte's not long enough for a Unicode character. So this is one of the major changes in going from Python 2 to Python 3, and that's why we're getting rid of Python 2. So Python 3 is what I'd recommend to do all your coding in. When you want to use a string, you have to denote that it's a string by putting quotes around it. So you can use single quotes, like here, or you can use double quotes. And the reason that there's different sorts of quotes that you can use is sometimes you want to have double quotes inside the string. And so in that case, it's easier to use single quotes on the outside of the string. And then it doesn't think that when it gets to if you started with a double quote and you got to a double quote here, it would think that that was the end of the string and wouldn't print out the double quotes like we wanted to. Similarly, if you had single quotes in your string, you can start the string with double quotes and end with double quotes, and so it knows where the start and end of the string is, and it just includes the single quotes there. But sometimes your strings are even more complicated, and you're going to have single quotes in there, and you're going to have double quotes. And sometimes you even want to have new lines in there, like dropping down a line. So in that situation, you can use triple single quotes at the beginning and end, or triple double quotes at the beginning and end. And see, these strings have got line feeds in them, so the line drops down from that side and continues on here. So I'm going to store these strings into these variables, S1, S2, S3, and S4, and then we'll print out the values, and we'll also look at what the type of an S1 is. So I'll press Shift-Enter, and you can do Shift-Enter at home, and you should get the same result. So you can see they're printing out just as we stored them, without the quotes on the outside. Notice with this string here, when it dropped a line, it's then got all these spaces before it came to line feeds, and these spaces here. So that's a disadvantage of. It's hard to make the code look nice when you've got these, so you would have to remove all those spaces there, and then when you printed them, you can see that they would line up. And finally, the type in Python of a string is str, so it's an abbreviation for string. Now for the advanced amongst you, sometimes you're going to want to use some special characters, like you are going to want to put a new line in the string, but you don't want to use the triple single quotes, or you don't want it to look like this in your code. So you can type a backslash and then an N, and that'll put a new line in. You can do a backslash and an R, and that'll give you a carriage return. If you've got a string that starts with a single quote and you want to put a single quote in the string, you can also use a backslash and a single quote. Similarly for double quotes. And of course, doing all that means that you can't just put a backslash in your code. So if you really do want a backslash in the string, then you would do a double backslash. So let's store all of these special characters into a string, and we'll print them out using this form of the print function, which has a comma between each of the variables, and I put numbers between them as well. So 1, and then our special character 1, 2, and then our special character 2, all the way up to 5 and our special character 5. So you can see it's printed 1, then special character 1 is the new line, so it's dropped down to the new line. The 2, we can't see the 2 anywhere. special character 3 is a single quote, so it's printed out the 3 and special character 3. So what this carriage return has done is it's printed it, but then it's taken where it's printing back to the beginning of the line and printed over what it's already printed. So not sure where you'd ever need to use that, but that's a function of what carriage return does. So the number 2 got overwritten with the space that's between each of these characters. So this form of the print statement prints each value separated by a space. And we've got all the end characters. Now another advanced, I'll mention it here because you might see them and you wonder what they are. Is sometimes you see a string, it's surrounded by quotes. So there's a double quote at the beginning, double quote at the end, but it's got a letter before the double quotes, and this is unusual. You don't see this in other languages. What the letter does, it tells you what sort of string it is. So if we see a U in front of it, that's a Unicode string. Unicode strings are the default in Python 3, but if you're doing Python 2, a Unicode string, you can now do that by putting a U in front of it. Similarly, a B in front of a string, that gives you a byte string, which is the default in Python 2, but you need the prefix in Python 3. So they're provided in both Python 2 and Python 3 because some people like to write code that will work in both versions of the language. R is a raw string where the backslash is just a backslash. So if you print something like that, it doesn't use the special characters as special characters, it just prints them out as backslash and whatever character it is after it. And F is a format string. Now we will use format strings tonight because they're incredibly useful. They're only introduced in Python 3.6, so they're fairly recent. Well, what that means is if you've got an F out the front here, you can put these curly braces inside the string, and then inside the curly braces you can put variable names, or you can put expressions like A plus B. And it will evaluate what is inside the curly braces and print that out. And you can see Google Colab has noticed that this stuff is not string characters, so it's even color-coded it with black rather than the red characters, which are the string characters. So let's print out all these strings and see what we get. As you'd expect, the first one is just a standard string, so there's nothing special there. Printing out the byte string, it's even printed it out with a B out in front. It's going, this is a special string, it's full of bytes. You really only use byte strings if you're doing communications, like serial communications, programming modems, things like that. But it'd be pretty rare that you need to use that sort of thing. The raw string, so let's have a look at these backslashes. So backslash is just a backslash, so it just printed out exactly as we've got there. And the format string, it evaluated A and printed out the number 3. It evaluated B as 4.5, and so printed out 4.5, and then it evaluated A plus B as 7.5, and so it put the answer there. And so I'm going to use format strings throughout tonight so that we can see the results of some of the things that we're doing. And it just makes it a lot clearer. So especially if you're not using a notebook, if you're doing this from a .py file, you can see the name of the file up here ends in .ipynb. That's Interactive Python Notebook. But if it ends in just .py, that's just a standard Python file that doesn't give us these interactive capabilities, but will just run straight through from the beginning to the end. Okay, any questions so far? I'm looking at the chat, there's no questions. So I presume you're all following. If you're having any sorts of difficulties, don't worry about asking me. This is supposed to be an absolute beginner's course, and even if I can't answer it, someone else might see your chat message, and they'll answer it as well. Okay, so we'll look at some of the operators. So these are the integer operators. So they're what you can do when, what you can use if you want to do sums with integers. So we've got two integers here, a is 27, b equals 5, and we're going to see what happens when we put a plus sign between them, a minus sign, an asterisk, a double slash, a percent, and a double asterisk. So as we'd expect, 27 plus 5, that returns 32. So it's just added those two numbers together, so that's just addition. 27 minus 5 gives us 22, that's just subtraction, so this is all pretty straightforward. 27 asterisk 5, that's used the asterisk for multiplication, so it gives us 135. Now double slash, when you want to do, when you want to divide one integer by another integer and you want the integer, you want the result to be an integer, you use double slash. And that's integer division. So 27 slash 5 is 27 divided by 5 is 5 remainder 2. So that double slash gives us the 5, and this percent sign gives us the remainder, which is 2. So it's also called modulo. When we want to do powers, we can use double asterisk. So that's 27 times 27 times 27 times 27 times 27. So it's 5 27s there multiplying by themselves, and that gives us a large number, and so that's how we would calculate powers. All right, so that was quickly going through integer operators. So floating point operators, they look pretty much the same. So we'll just have a couple of floating point numbers here, and you can see a floating point number is designated by putting a decimal in there. So even though they're an integer value, the 27, by saying 0.0, we want it to be a floating point number, and all the calculations will be done as though they're floating point numbers. So if I run them, we can see that 27 plus 5 gives us 32.0. So it's worked out that they're floating point numbers, so it's given us a floating point result. Similarly, subtraction works the same way, multiplication works the same way. And now division. Division, we've got two ways of doing division. We can do division for a floating point number, which will give us 5.4 as the result, or we can find the integer quotient and its remainder using double slash and percent. But it's still a floating point quotient, even though it's whole number division, but it still returns the number as a floating point. And similarly, power gives us the power as a floating point number. So what would have happened if one of these numbers was an integer? Well, let's see. Let's make b an integer. And we see it's a floating point number plus an integer, and that returns a floating point number. So if one of the numbers is a floating point, then it will return a floating point number. So what if both of them were integers? And I'll run that again, shift enter. And now all of them are returning integers except for the floating point division, which is the single slash. So I'll just leave that back at floating point, but you can play around. You can even type in some different numbers there and see what happens. So that's done some calculations for us using different numbers. All right, now there's probably some people here are finding this too easy, so I thought I'd throw in some the bitwise operators. So that's things like the vertical slash, the ampersand, the circumflex, two less than signs, two greater than signs. So what do these operators do? So we'll put I left them as 3s. Anyway, that's good. So we're going to use a as 10, b equals 3, and let's see what we get. So 10, this is OR. It's called bitwise OR, 3, and the answer to that is 11. So try to work out how that works, and I've converted these numbers into binary. So 10 in binary is 1010 because that's 8 plus 2, and 3 in binary is 0011. So when we do a bitwise OR, it's a 1 if either of them are 1, or otherwise it's a 0. So we've got the first digit is a 1 because we've got a 1 in 10. The second digit's a 0 because we've got a 0 in both of them, the second digits. The third digit's we've got a 1 and a 1, so that'll give us 1. And the fourth digit's a 0 and a 1, so that'll give us OR of 1. Similarly, we can do ampersand, which is bitwise AND. So it only puts a 1 if both the digits were 1. So in our case, that'll be 0010, which is 2. And sure enough, that's the answer 2. The circumflex is exclusive OR. So the two numbers have to be different, and then it will come here. So only the first and last digits in binary are different. So they'll be the 1s, and the middle two will be 0s. So that'll be 8 plus 1 equals 9. That gives us 9 as the answer. This operator here shifts the binary left 2 places. So if we have 0011 and we shift all those bits left 2 places, we'll get 1100, which gets converted to 12. And similarly 13, shift right 2 places, will give us 3, because we get 1101, we shift that right, we get 0011, and these 2 places that got shifted right, they just fall off and are forgotten. So we're just left with the 1, 1. You can study my print format strings to see how I've printed out the binary. I've just used this B to say I want it printed out in binary, and I've also used a width to say I want it 4 characters wide, and I want any leading characters to be replaced with zeros. Any questions yet? Let me know if I'm going too fast. When do we need to use bitwise operators? So it's pretty rare that you'll use a bitwise operator, so that's why I've stuck it down as advanced. The places I've seen bitwise operators used when people are doing things like serial communication. So they're programming embedded devices, or they can be using Raspberry Pis that have got switches coming in, and they need to do the calculations on those. Another time I've seen it is in encryption. So a place I've actually used bitwise operators is when I've been, say, validating BPay numbers. So BPay numbers, they have a checksum at the end of the number. So you run these bitwise operators on the first so many digits of your BPay number, and it will come up with an answer of, say, a 2-digit number, and you check if the last 2 digits of your BPay number are those 2 digits, and if it is, then you know that the person has typed in their BPay number correctly. All right. Now, operators plus and asterisk, they can also be used on strings. So here we've got a string which is well, and we're multiplying that by 3, and then we're adding that to a string 3 holes in the ground. So let's see what happens when we do that. We get well, 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 because that's the first string multiplied 3 times, and then it gets added to 3 holes in the ground, and it all becomes one long string. Adjacent strings don't even need the plus. So you could just have these, I've got these strings here with a 1, a 2, a 3 and a 4, all using different quotes, and I've got spaces in the strings. And if I get to see what that evaluates to by pressing Shift Enter, it's a single string with 1, 2, 3 and 4. All right, so we've been dealing with the different data types. Interesting side effects of especially the ints and the floats. Ints can have more significant digits than floats because all floats use the same amount of memory, but ints will expand to use the amount of memory for the size of the integer that they are. So sometimes when we're doing calculations that require large degrees of precision, we can use ints rather than floats. So for example, if I do 25 divided by 7, that's going to be a float. But if I do 25 with all these zeros / / 7, then let's see what we get. And you can see this is the floating point. It's only got about 17 significant figures, but the integer will keep going longer and longer and longer. And I've used that characteristic when I've been calculating pi to say 1,000 decimal places, and I just keep using bigger and bigger ints. Okay, so I've got, someone's asked, can you tell how to decide which machine learning model we can use for our problem? So we're not really discussing machine learning at tonight's session. So the sessions that Arun takes, he will talk about machine learning quite a lot. So we're just doing straight arithmetic here and data processing, which with the strings. So next Tuesday, Arun will be dealing with machine learning, and so you can ask that question then. And he'll have particular machine learning problems that we'll be working on. So each one he'll show you how to use, what the effects of different models are. So these are the very basic data types. You'll be using these basic data types to build up to the data structures that you use in machine learning. So it's good to understand these first before you get into machine learning. All right, so we'll talk about side effects, floats. Because of the way they store their numbers, they can't store decimal numbers exactly in binary notation because all numbers are stored as ones and zeros inside the computer. So floats are very good for using scientific applications, but they're not so good for accounting because in accounting they don't like it when you get slight inaccuracies. So in this case, if I wanted 1.1 and 2.2 and added those two numbers together, I ended up getting 3.3000003. So as far as science goes, that's good enough. For accounting, that doesn't work. But science needs to have the bigger range of numbers that floats provide without using up too much memory. So they're good, very good for science. There's other ways in accounting. You could do everything in cents, then you could use integers rather than floating point numbers. Or if you want to use dollars, there's another class called decimal, which you could use if you're doing accounting. Decimals are a bit harder to work with, so I won't be demonstrating them tonight. All right, so now's the chance for you to do some yourself. So I've put a couple of challenges here. I've put even some blank cells. So you type into the blank cell what you're going to do to calculate and display the result, and then you run the cell by doing Shift Enter, and you should get the result. So I'll leave this to you, and while you're working on that, if anyone's got some more questions, I'm happy to answer them in the chat. And feel free to start typing answers into the chat as well. If you come up with some answers, you can type some into the chat, and then I know where you're up to. Okay, I'll get started with the first one. I can just type 1, 2, 3, plus 4, 5, 6, and press Shift Enter, and it tells me 5, 7, 9. So the next one's going to be interesting. How do we do both the quotient and the remainder from dividing 666 by 235? So we're doing integer arithmetic here because we want the quotient, an integer quotient, I should say the integer quotient and remainder. So we can type that to get the integer quotient. And if we put a comma between that, we can actually do the other thing, the other calculation on the same line. And I press Shift Enter, and it'll work out both those values, puts them in a group here. That's called a tuple, but we'll talk about that later. And so the first answer is 2,836, remainder 206. Okay, 2 to the power 10, Shift Enter, and the decimal quotient. All right, so now we're going to store in a variable the name of your favorite Python programming language as a string. So let's call it favorite. Call it favorite language equals and a string. So we can use double quotes for that. All right, so that stores it in a string, and then we want to construct a new string that starts with programming in. Okay, so I'll start with programming in, finishes with is fun, and includes the value of the variable in the middle. So there's a couple of ways we could do this. Is fun. So there we go, it's given us the result. Programming in Python is fun. So let's have a look at another way. So I'll do Command M below, and I could use a format string. So by putting an F out the front, and that worked as well. So we could change this. We could say Jupyter Notebooks and run that. It says programming in Jupyter Notebooks is fun, and if we run this one, we also get programming in Jupyter Notebooks is fun. Let's have a look at the solutions. I've used format strings to show the answers down here. Nothing really special. I've stored both of them in strings here, C1 and C2 for the challenge. So when we run that, we also get those results. Okay, another data type that we can consider is bool, which is the Python name for Boolean data types. And Boolean data types store true or false, and they're the result of using a conditional operator. So if I look at what the type of them is, see I've put the comma between it, so we're getting two results. The type of true is bool, type of false is bool. And if you remember from my keyword list before, true and false are both Python keywords. All right, so how do we evaluate something that's going to return a Boolean? We can use these operators. So here's the double equals sign. What does that give us? That gives us true, because it evaluates 5 minus 2, comes up with 3. And it's got 3 on the left-hand side. And the double equals is actually, that's saying is equal to. So remember, a single equals is assignment. If you just had a single equals there, it would try to assign what's on the right-hand side to a variable name on the left-hand side. But when we use double equals, then it's comparing the two. And that's why there's a difference between single equals and double equals. Let's see this one. We can use greater than. Is 45 greater than 23? The answer is true. Is minus 10 less than minus 20? The answer is false. Does C1 equal Python? True. Okay. That's good. And if someone had typed in a different favorite programming language before, then that would come up false. So, a challenge. I've got all of these operators I've used, and the question is, try to predict the outcome of the following Boolean expressions, and then run it and see if that's what you get. So, yep, go through those and see. C1 equals Python. We just did one very similar to that up here. C1 equals Python, so see what we get there. So work your way through those. You can even press Shift-Enter if you want to see the answers. There we go. So for the first one, C1 equals Python returns false, because C1 is Python with a capital P, and that's Python with a lowercase p, so that they're not equal. So if you did C1 does not equal Python, then that will return true. And I'll give you a couple of minutes on those. Any questions, just ask me in the chat. Okay, we'll have a look at these. So we've done the first two. 253 is greater than or equal to 1518 divided by 6. Now 1518 divided by 6 is 253.0, as we can see in this one. Now you can use equality between an integer and a floating point number. So they're both actually equals. 253 equals 253.0. So if it equals, then less than or equal will also return true. So those both return true. We looked at math.e. So we've brought in this math library and we've looked in e. So e is the base for natural logarithms and pi is the ratio of a circumference to the diameter of a circle. And so it's substituted in those numbers. That's the value of e, 2.718, etc. And pi is 3.14159, etc. And so yes, e is less than that. Now in the math library there's also tau. Tau is the ratio of the circumference to the radius of a circle, which is in fact 2 times pi. So let's compare math.pi times 2 with math.tau with a less than sign there. You see the two numbers, they're the same, so that'll be false. So we see we've done it with 3 expressions here, so we've got 2 operators. So it starts from left to right. Here's 2.718 is less than 6.28, that's true. Is less than 6.28, that number's not that, so that returns false. So it's like an and. That has to be true, and that has to be true. A is less than C, that returns true. The way strings are compared, it looks at the Unicode values, which is a number, and C, so the number for A is 2 less than the number for C. So lowercase a is less than lowercase c. But if you compare lowercase a with uppercase c, you'll get a surprise because that's false. Because in Unicode, as in ASCII, all the uppercase characters appear before the lowercase for our standard alphabet. I'm not sure what it is in other alphabets, but in Unicode that's how the Western alphabet is evaluated. So therefore upper is going to be less than lower. So what this, all the uppercase letters is going to be less than lower. Catch is less than carriage, returns false. So it compares the C's, they're the same, compares the A's, they're the same, compares the T to the R, and goes, nope, the T is after R, so that gives us false. Similarly, I've got a list here. We haven't done lists yet, but here's a list of numbers, and that will return false because it starts the same way as strings. The first one, 5, is greater than or equal to 6, is false, so that returns false. There's an operator called in, and that can be used to see if a string is inside another string. So at is in catch, that's true. AC is not in catch, even though A is in catch and C is in catch, but AC is not in catch. So that's false, and TA is also false when you compare it to in catch. Lists 2 and 6 not in 5126 returns true because only one element of a list can be checked within. So you could say is 2 in that list, and that would say well, 2 in the list is true, 2 not in the list would be false. We can use these logical ors and ands. So true or false returns true, true and false returns false, true or false and false returns true, because and has precedence over or. So that bit is worked out first, false and false, and so the result of false and false is false, and then true or false is true. So the overall answer is true. Similarly, false and false or true returns true. is C1 is C2. That returns true. Let's see. We said C2 equals C1. And remember they were strings. So then if you compare them with is rather than equals, it'll say true because they are now referring to the same location in memory. And most of the time that will be correct for you. But what we're dealing there is immutable objects, data types. So strings are immutable, and that's why that returns true. And later we'll look at other ones which that doesn't return true for. Any questions on that challenge? There are a few easy ones and a few hard ones in there. Did anyone get them all right? No, it would be surprising to get them all right. I had to think about a few of them. Okay, let's talk about lists now. I showed you a bit about lists before, but we can define a list just with square brackets. So we've got a variable name here, we called it LST. Whatever you do, don't call it LIST because that will be, there's already a function called LIST. And if you call your variable the same name, then you won't be able to use the function anymore. So I'll call it LST, and I'll put some things in there. I'll put a string in it, I'll put an integer, a floating point, another string, and a few more strings. And so if I print those, it prints it in a way, it's pretty similar to how I put it in, so I can see it's a list. Now I can refer to different elements within the list by using the index. And the index starts from zeros, because list is 0 index. So that's 0, 1, 2, 3, 4, 5, 6. So list 0 returns the string SIX. List 1 should return the integer 5. Yes. And list 6 should return the string 0. Now something that you can do in Python you can't do in other languages is you can start counting the index back from the end. So if you put in -1, it starts at the end and goes, that's -1, -2, -3, -4, -5, -6, -7. So list -1 gives us the string 0. List -2 gives us the string 1. We can use this function len to find the length of the list. And len can be used for other things. You find length of other objects as well. So the length of our list is 7. One of the powerful things you can do in Python is you can slice a list. So where you're putting an index, you can put a range of numbers with a colon between them. And so that'll take all the elements starting from 2 up to, but not including 5. And that means by not including the 5, it means you can always be confident that the number of elements that you get is going to be the second number minus the first. So 5 minus 2 says 3 elements. So we're going to get 3 elements by this. So let's have a look at what that gives us. It gives us a sublist 4, 3, 2. When using the colon, you can leave the first number out and it will assume 0. You can leave the last number out and it will assume -1. So it'll go right up to the end. You can even put in 2 colons. So if you do 2 colons, the first number is going to be where you start from. The second number, as we've done before, is going to be where you go up to. And the third number is what step you're going to go in. So we want to go from index 1 up to the end, so we've left it the blank, and we want to go up in 2s. And so that gives us 5, 3, 1. You can even step backwards by putting in negative numbers. So we can turn the list around and go all the way back to the beginning . but not including the value with index 1. So 0, 1, 2, 3, 4. And so let's have a look at what's currently in list. List is this, 6543210. Now we want to assign item at index 2 with a string. We're going to put the string FOUR in there rather than the floating point number 4.0. So we can do that using the equals for assignment, and we can assign it straight to the location 2 of the list. So let's do this and see what list looks like after we've done it. So now list looks like 65 and capital FOUR 3210. That also works, of course, with the negative indexes, and we've changed the last to blast off. Now strings can be handled, they can do many of the functions that lists can do. Like you can do this slicing with strings. So if I do the slicing, I should get D, E, F, G. So it's A is 0, B is 1, C is 2, D is 3. And it's gone up to, but not including number 7. So it's given us 4 characters, and they're D, E, F, G. So the next challenge is find out what is something that you can do in a list that you can't do with a string. So try going through some of these things that we've just done with lists. You might need to make a few empty cells. So MA, MA, MA. So that's Control M, then an A, Control M, then an A. So you've got a space to type things in and start doing some of these operations that we've just done on lists and do them with strings. So can we find the 0th index of a string? Let's try that out. S0 gives us A. Yes, we can do that. All right, so have a go at that. The first person who finds something that breaks, type it into the chat. And while you're working on that, I can answer any other questions in the chat. I see there's some latecomers, so if there's anyone who's come late and needs to know how to get into the notebook, you can ask a question about that as well. Okay, Peter's come up with one. He says if we type this in, we can't, it doesn't work. I would have thought it would work actually. Yeah, that works. Why doesn't it start at 0? Oh, okay, yep, so when we start at 0, it does start at 0. List :1 :-1. The first comes out as 0, 1, 2. So that one, because it's worked out that the step is a negative number, it will always start at the end. That's by default. So this becomes the last one by default. So we could go -1, we could put that in, and it should give the same answer. Yep, well, of course we've changed 0 to blast off since then, but now it's reading blast off, but yes, it's the same answer. So, yeah, I think Peter's asking a question about lists rather than strings. That's why he used LST. Right, so Alex says string doesn't change when you change an index, so that's right. So if I tried saying S3 equals Z, I'll get an error. A string object does not support item assignment. So the reason that is strings are what we call immutable. You can't change a string. You can put a new string into a variable, but you can't change an existing string. While lists are mutable, you can take an existing list and change something that's in there. And yep, that's, if I look at the solution, we'll start with S equals 6543210. I get 0, 1, 2, 3, 4 for that one, and yeah, I'll get type errors for these. So I haven't evaluated them because I know that I'll get a type error. Okay. So, interesting facts. We can convert a string to a list using this function list. There we go. And in fact, you can do that for a lot of data types. So if I wanted to say int of 5.4, it'll give me 5. Or if I wanted to say float of 3, it'll convert 3 from an integer to a floating point number. Sometimes I can have a string value of a number as well. And so it's taken the number and it's converted it to a string by putting quotes around it. So here we are, we're converting a string to a list. And we look at the list, and it's taken each character from the string and put it in as a separate element in the list. So you think, could we convert it back, using the string function to convert it back? But unfortunately not. That takes the list and puts quotes around it. So that's what our string from a list looks like. However, you can use the join function. So join is a function of strings. So we can take an empty string, we can run the join function on it, which just means take every item from our list and join all the list items with this string. So in this case, the string is an empty string, so they should all be combined together. And that gives us a string back, 6543210. Now, we could have put dashes. We could join them all with dashes. And we get 6-5-4-3-2-1-0. But that's the one we want. Okay, so up until now, we've just been using Python as a calculator, and really a lot of people using interactive Python, they can do incredibly powerful stuff, especially in the data science and machine learning fields. But if you want to do programming, then we need to create some program structure. You've seen how I've been able to put more than one command into a cell, and it runs them sequentially. It starts from the first cell and works its way down until the first line works its way down to the last line, just running them one at a time. But sometimes you want to change which lines get executed depending on some sort of condition. You make the computer make a choice of which way to go. And that's where you really get the power in languages. So we're going to use, we can use the if-then, if-then structure. Then's not actually a Python word, that's from other languages, so I might just change that. But we do if, and then our conditional operator, which will tell us whether something's true or false. And then we have a code block of block of code that we want to run if it's true. And we can even provide an else and a code block to run if it's false. So in our example here, we're going to find a random number. We're going to use, from the random library, we're going to use a function called randrange. And randrange 6 will return an integer between 0 and 5. So we're going to pretend it's a die roll, so we'll add 1 to that. And then we're going to check if it's an even number or an odd number. So to check that, we're going to use modulo 2. So we're going to divide it by 2 and see if there's a remainder. If the remainder is 0, we know it's even. Otherwise, it must be an odd number. So let's see what happens when we run this. You rolled 3, which is an odd number. Run it again. You rolled 3, which is an odd number. You rolled 2, which is an even number. So you can see it's making a decision about whether the die roll returned a even or odd number, and then running different code depending on that. Now the code block is indented, and that's what Python does to work out where your code blocks are, is by the indentation. Now normally in Python you'd indent by 4 spaces. In Google Colab they do 2 spaces by default. So it will work, and that will work in other places, but you'll get warnings, and it can be confusing if you start doing code indented with 2 spaces with other people who've got code indented by 4 spaces. When you come out of the indentation, that says that's the end of the code block, and it starts the new code block, or it starts the new line. It runs it, and just about any time you're going to have a code block, you'll have a colon there. Say the next line is going to start a code block. So else, and then start of a code block. After the if, we've got a start of a code block. We can even, the if structure also allows us to do an else if, which is in Python is ELIF. So it'll do this condition, else it'll check this condition, and if that one's also false, it'll then do this else. And you can have lots of else ifs. So what I'm going to do here, I'm going to roll the die twice, and the first number I'm going to store as the first element of a list, and the second number I'm going to store as the second element of the list. And then I'm going to say what we rolled, and then I'm going to compare the first one with the second one. If they're equal, I'm going to say they're both equal. If the first one is lower, I'm going to say that, and otherwise the only other option is it must have been greater than. Now, you'll notice some things here in the code. I wanted this to all show up on one line. So in the print statement, in the print function, I did a comma, and then I said end equals space. So by default, end is start on a new line, but I've changed the end to be a space. So it'll print that, put a space, and then it'll print one of these on the same line. So let's see what that looks like. Shift Enter. You rolled 1, 1, space, space. They are both equal. All right, so I've got a double. You rolled 2, 3. First roll is less than the second roll. Now, are there any questions about any of that? There's quite a lot of code in there. Is there any lines that you don't understand what they're doing? Anyway, just ask on the chat if there are. So that was if, which allows us to branch. Now, sometimes we want to loop, and there's a couple of ways of looping in Python. We can use for loops or we can use while loops. And that's where you want to do the same code block many times. So the way a for loop works, we say for, and then we put in a variable name, and every time through the loop, that variable will have a different value. And it gets its value from whatever's after the in statement. So this is in, the same, it's spelt the same way as the in we were using before to see if something was in something else, but it's used for for loops in this way. We've got a list here, so we can iterate through that list, choosing one item at a time, and it will print it. So the first time through the list, through the loop, number will be 3, the second time it will be 2, and the third time it will be 1. So print that, it comes up on different lines, 3, 2, 1. Here's an example of a while loop. So while loops are like an if statement. You've got a condition in there that's true or false. If it's true, it'll keep running that bit of code in the code block. Rather than if statement just runs it once, a while loop will run it over and over again until that becomes false. So you've got to make sure that there's something in here is going to change the evaluation of that. So I've got a line here, counter plus equals 1, which is a shorthand way of writing counter equals counter plus 1. So every time through the loop, counter will get a new value, which will be 1 more than its previous value. And so it'll do the loop until counter is no longer less than 10. So let's run this. And here we go. There's counter, 0, 1, 2, 3, 4, up to 9. Of course, once it's 10, it doesn't do the loop because 10 is not less than 10. It tells us the 2 rolls of the die, and it says the first roll is greater than the second roll for that one. And so we didn't get any doubles in that list. So let's run it again and see if we get some doubles. Yep, so we've got they are equal. We've got some greater thans, we've got some less thans. Okay, so challenge 5. Write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. Okay, so to save you some typing, I've typed out all the names of the numbers there and put them in a list. So you can use that value for that variable numbers and start working on your program script. So you put it all in one cell and see how you go. Okay, so while you're working on that, I'm going to answer one of the chat questions. Which is, what does the end do in a print statement, a print function? So if I say print hello, and then print Pythonistas, that will print on 2 lines, hello Pythonistas. And the reason it does that is because there's a parameter to this print function called end. And you see, as I'm typing it in, it's telling me what the default value is. The default value is \n. So if I typed in \n, I would get exactly the same behavior as if I didn't put anything in there. That's the default value. So you can see if I run that, I get hello Python nesters with a line in between. Now I can put anything on the end of this line, like I can do exclamation marks, and it'll put 2 exclamation marks on the end of each line. Now say I want the exclamation marks, but I don't want it to jump down a line. So I'll take that one off there and run that. You see now it puts hello Python nesters all on the one line. It's got the end character, which is the end of everything that it prints here, is going to be the double exclamation mark. Okay, does that make sense? Alex has given a good answer in the chat as well. Any other questions? How are you going with it? We're going to write a loop here. So do we want to use a for loop or a while loop? While. Yep, we can use while. It is actually possible to use for, but you need to know something that I haven't shown you yet. So one thing you could use is the index function of a list that I've got to run this one first. That you give it a value that's in the list and it'll tell you what index that is. So the string THREE has index 3 in that list. All right, so how many lines of code do you think we need to write to, what's the minimum number of lines of code to do this challenge? So I'll show you another thing. We could say, all right, Alex has got it down in 2. Very good. Anyone else get 2? So you'll need to use inline if statements. Yes, it needs to be readable. But it's a lot of fun trying to do it in 2 lines. Oh, Alex saying it might be possible in 2. Okay. All right. Well, I'll give you a clue. So let's see. I'll write odd, even equals even if so say we've got a number n, if n else odd. Equals 4. So if I say n equals 4, so you can use this inline way of doing if else. So it takes the first value only if this is true, otherwise it takes the second value. So the other thing you can do actually, if you say equals 0, it will, sometimes you can have your conditional return 0 or not 0, and so anything not 0 will be true and 0 will be false. So let's do this. So 5 is odd, 6 is even. How could we use this in a 2-line program, assuming numbers is already defined? Well, actually, we could put that all in the first line as well. So we could say for number in numbers, print so we want to print the number, numbers, we want to print the index of number, we want to print the number itself, and we want to print odd if numbers dot index number %2 else even, and close parentheses. Okay, this is just a Google Colab thing, probably because I've been waiting around for too long. So there's the answer in 2 lines. For number in numbers, we print the index of the number, we print the number itself, and then we check if it's that index is even or odd. Of course, it's pretty hard to understand what's going on there. So I've got a solution here, which is using the while loop. So we start I is 0, so I is just our index. While I is less than the length of the numbers, we're just going to loop through it and increment I 1 time each week time we go through the loop. And we're going to work out if category is even or odd. We're going to print the I, the category, and numbers I. So it's possible that this is even faster than our 2-line program, because in the 2-line program we we had to calculate this index twice because we were trying not to have another line in the code where we stored that number in a variable to be used later on. So let's see if this one works. Yep, it gives us the same answer. Okay, any questions about that challenge? How many lines did you take to get it to work? Peter was going to use 4. Did you use 4, Peter? Okay, if you want to check how long something takes, we'll use the datetime library. So we say we'll do a timestamp equals datetime dot now, and then we want to print how long it took, which is datetime dot now minus the original timestamp. Oh, I've got to import it. I didn't run that one. So here we go. It took 1837 microseconds. And we'll do the same thing down here. Because it's a lot more accurate than if they run it just once. So we ran it once, 1837, 13,119 microseconds. Yep, so it's showing the 2-line version was faster. But yeah, you'd put that in another loop and run it 1,000 times. And then see how long it took. But we've got print statements in there, so we don't want to be printing out vast quantities of data. So we'd have to take the print statements out, but of course then that doesn't work for this one, which is what we're timing is the print statement. Okay, well that's all I've got all I've got on today's session. So I hope you learned something from that. Oh, if you want to actually install Python on your computer, you get Python from python.org. I've got some instructions here on my Pythonator website. And it's so it just suggests you go to the Python website, which is python.org downloads. And that's where you get Python from, so download Python 3.8.2. When you're installing it, just using the default settings are fine. I like adding this one here. There's this add Python, it'll be 3.8 now, to path. So I tick that box, and that just makes it easier if I want to run Python from the command line. Not something that you'd want to do often, but it's just when you do, it's nice that Python's then available. You can set this up later if you've already installed it, but you have to know how to set your path environment variable in Windows to be able to do that. Okay, back. If you want to try my Pythonator course, which is more designed for kids, but they go into a mind test world, which is just like Minecraft, and they build stuff. So some of the things that they build they explore the world and they come up with these signs that tell them what they have to build, and then they have to write Python programs, and they write the Python programs that link into the Mindtest server and builds the things that they've been tasked to do. And if they get it right, then they get on to the next task, and they get extra privileges, like they be able to fly or they can go fast, and they can see, because it's a 3D world with other people in it, they can see how other people are going in the world. So feel free to have a go at that. It's all free. I was using it at Coder Dojo for kids. It requires PyCharm Educational, so you'll need to install PyCharm Community Edition and then add the EduTools plugin, and the instructions are on the Pythonator site on how to do that. If you like the video, click on like, and next week we'll have Arun will be taking the session. He'll be doing machine learning, so he'll be, I'm not exactly sure what he's going to be doing next week, but he always uses pandas data frames and then some of the machine learning libraries on top of that. So that'll be at the same time. It'll be a different link because he'll be broadcasting from his computer. But if you look at the meetup group, that'll have all the links that you require. I'm going to end the stream now, so I'll keep watching the chat for another 5 minutes. So if you've got any more questions, feel free to ask. We'll be listening to the Slack channel all week. If there's anyone who wants to get onto the Slack channel, the instructions are on the meetup page on how to join the Slack channel, and you can ask questions on that. Thanks for your time. See you later.